I have an exciting tutorial for you guys this time. Check it out. We are spawning a forest as I run behind us, complete with animation popping up over time. It's really quick, so it's not too jarring. And as I continue to run, you can see it spawns more and more. And the great thing is, if I stop running and then I quit, and then when we play again, the path that we have taken, the exact path, is now back. And we can go ahead and run some more and spawn more. I can change my radius and it will update everything. And again, quit, play. There's our new path that I just ran. So let me show you how to set this up. Here we are in a brand new project using a third-person template. So I have a character reference. I'm going to go to Edit Plugins. Then I'm going to search for PCG, and I'm going to make sure to turn on the Procedural Content Generation Framework, hit yes, and restart my engine. After we're done restarting, let's go ahead and set up the forest. So I'm going to right-click, go to PCG, go to PCG Graph. If you get some templates, don't worry, we're not using any templates. Just go ahead and click Create Empty Graph. Otherwise, it should just pop up as an empty graph right away. I'm just calling it PCG_forest. Besides the PCG graph, I'm going to need a blueprint. So I'm going to right-click, go to Blueprint Class, and select an actor. I'm going to call this BP_forest. Let's open up the blueprint. In here, we'll go ahead and add ourselves a PCG graph, and then set the instance we created as our graph in the instance. Now, I am going to want to load this on demand at runtime. So I'm going to change the generation trigger from generate and load to generate on demand. And because I need it to be at runtime, I need some kind of volume. So I'm going to add a simple box collision here. It could be any collision at all, because in the detail panel, we're going to go to collision, and we're going to change the collision presets here to be no collision. I just need some kind of volume for the runtime aspect of it. And then we're good for here. At this point, we can go ahead and just drag down to the world. I'll go ahead and place it just in origin for convenience. But let's go ahead and open up the PCG graph. For this version, I'm going to make it simple. I'm just going to use a create points grid. You can absolutely use your own points. You can make it on interior for supply. You can do whatever you want. This is just for demonstration as a simple method here. I'm going to make it quite large. So I'm going to make it 5,000 by 5,000 on X and Y. The cell size, because it is going to be spawning smaller things, I'm going to make it 30 by 30 on X and Y. We can leave the Z as is because it's only a flat plane, so this is fine. The coordinate space, we do want to change to local component though. So that way, if we move this grid, it will come along with us. And the rest we can leave as is. At this point, I can drag out of create points grid, use a transform points node so we can randomize these points a little bit. And because they're 30 by 30, I'm going to offset them min -15 in both X and Y and up to +15 in X and Y. I'm also give them an option of rotating 360 degrees, and I'm going to have them scale anywhere from a quarter size to its full size. So we get some variations in scale. The rest here I can leave alone. With it selected and the blueprint in the world, I can press A, and then in the new 5/6 viewport, you can see here's our points. And you can see some of them are bigger, some of them are smaller. They're randomly rotated here. From here, we just need to prune a few. We're going to use a select points. This is only going to keep a certain ratio of points. I'm going to keep 70% by setting it to 0.7. Again, if I click A and look at my new viewport, you can see there's a lot more empty gaps between the foliage, or rather soon to be foliage. So it is just going to be a lot more natural. At this point, I can already use a static mesh spawner. Now, before I add the mesh entries to the spawner, there is going to be one change I'm going to need to do, and that is to the little blades of grass. By default, if I use the PCG saplings, as they're called, they don't have a collision, and I needed to have a collision, but I don't want to mess with the ones in the plugins or engine directories directly. So what I'm going to do is make a copy of it, add collisions to that version, and then use it. We can find where it is easily by just adding a new mesh entry, opening it up, and under static mesh, we can search for PCG. And there's quite a few options here. We're going to want the PCG seedling here. I'm going to press the Browse to Asset button. You can see it's already spawned everywhere, but we basically need the seedling. So I'm going to take it and I'm going to copy it to the PCG folder by dragging onto there and clicking copy here. And then I'm going to rename this to PCG_my seedling 01. I'm going to open it, and then here under collision, I'm going to just click add box simplify collision, and you'll see a little box appear around it. That is good enough for collision for us. We just need to trace onto it to get the information we're going to need later. Now in the PCG graph again, we can replace static mesh with my seedling, the one that has the collision. But of course we need to modify the collision on this because we just set a box for it. So I'm going to scroll down a little bit, and you'll see collision preset. It might be closed up for you here. you'll see no collision. So we want to make sure that is open because we're going to change no collision to custom. Collision enabled instead of no collision. So we want query only. We don't care about the physics on here. And the object type can be left alone. But the collision responses, we want to set everything to ignore, and we're going to use visibility to block. If you're doing this for yourself, I would highly recommend you set up your own custom collision channel. That is not part of this tutorial. There's others on YouTube that show how to create custom collision channels and use them. But just know, as a recommendation, it would be better off if you made a custom collision channel and used that. But for this is all we need. But this is only going to get us the actual seedlings. I would like to also spawn some trees. So I'm going to add one more mesh entry. And in this mesh entry, I'm just going to search, again, PCG. I'm going to grab one of the trees. And just like the other one, I'm going to scroll down here. I'm going to open up the collisions, custom, query only, set everything to ignore, and then set visibility to block. But I also want the trees to block the player. So I'm going to also set the pawn to block. If you're using a custom trace channel, that's what you would select here. Now, if you take a look, well, there's a lot of trees. Oh boy, there are a lot of trees here. In fact, pretty much 50% of everything here is a tree, and that's just too many. So we want to have far less trees. You can absolutely separate the select points out and have a separate select points here that does something like keep only 5% and then spawn the static mesh separately. Or the alternative is under the mesh entries, I'm going to open the seedling, and I'm going to make the seedling 100 times more likely to appear than the tree. So pretty much for every tree, there's about 100 blades of grass. And you can see that's a lot better now. Now, in my case, I made this a little bit bigger than the ground. So I'm going to just extend the ground here. And if we take a look down, you can see this is the actual density of 100 trees. So if you want to have a little bit fewer trees and have like more open areas like this, you can just tweak the value as you'd like. Now this is great, but we want to spawn the forest as we run. We don't want to just have it spawned in right away. So what do? Well, what we're going to do basically is we're going to shrink all of these things to be very, very tiny to effectively be unseen. And then as we run through it, we will scale them back up to full size. Now to do that, we will need another transform points right after the select points. So go ahead and add it in. And in this transform points, all we need to do is just change the scale min and scale max to 0.001 for everything. So that way it's uniformly scaled to just very small number. You can make this, of course, even smaller, but the values that I'm going to be showing you kind of work with this one best. So now I hit play. You can see it effectively makes them disappear. At certain angles, you might actually notice like a speck here and there, but let's be realistic. Once you have an actual ground plane and not just effectively a shiny floor, you will not notice anything. So great. So now how do we make it appear behind us? Well, we can do that with some blueprint logic. So let's set that up. Now I'm going to be putting this on the third person character. You can absolutely do it on anything else. So in my case, I'll open the third person character and then I'm going to just scroll all over and just go here on the right where there's some free space. Then I'm going to right click, search for event, begin play. And then we're going to do a set timer by function name. Now we don't have a function yet, so let's go ahead and make one. If you're in previous versions than 5.6, you might not have this move and aim, so don't worry, this just comes with the new 5.6 templates. So you can ignore the functions that I see here. I'll go ahead and add a new function, and I'll just call this grow forest. Now I'll go ahead and take this name and copy it, and then put it into the function name of this node. And then I want to have it loop, and I want it to loop every 0.01 seconds. So it becomes relatively smooth and it will continuously loop. It's fantastic. So this is good. Let's go ahead and go back to our grow forest function. What we're going to need to do is basically do a trace behind the player as they run in a certain radius. So that way we can get specifically the components that are just behind the player. So if you have hundreds of thousands of points, you're not actually loading hundreds of thousands of points. You're only loading the ones in that little area. To do that, what we're going to do is just drag out and search for a multi-sphere trace by channel. Now, in my case, I'm leaving it on visibility. But again, if you set up your own custom channel, this is where you would select it. The radius I'm going to set to 100 by default. I'm also going to right click on radius then and promote it to a variable, or just leave it the name radius. So that way I can modify the radius later to have a bit of fun to randomize things. And now we need to get the trace location. Now again, I want to do it behind the player, but also on the ground where the feet are. I don't want the trace to be up in the air. I want it to be on the ground and a nice radius. So we first get the actual location of the character. So get actor location. so we know where the player is. Then we want to subtract the half height of the capsule because this is by default in the middle of the character. If I go to the viewport, you can see this is actually the center of the character where the arrow is. This part is in negative and this part is in positive technically based on the actor location. So what we're going to do is grab the capsule component, drag it in, and then drag out and get scaled capsule half height. We need this guy right here. Now, to plug this in, we just need to right-click on the second pin here and split it so we can get XYZ separately and plug this into the Z. So we only move it by the half height down. Now that's great, but we also want to move it back because as it is, it will be on the bottom of the character, but all around us. And if it's all around us and we're spawning trees that have collision, we might just spawn a tree right in front of us and stop. We don't want that. We want things to only spawn behind us because of that. So I'm going to move this a little bit down, and then I'm going to do get actor forward vector, which tells us which direction it is facing. Then I'm going to go ahead and multiply it by the radius. I'm going to take the radius, duplicate it, and plug it in to the second option. It's going to convert it to a float, which is great. But this will move it in front of us because get forward vector is positive. I want to move it behind us, so I'm going to make another input here. Then I'm going to right click and convert it to a float. You can also convert it to an integer because I'm just going to make it -1. So it is going to go in the opposite direction based on the size of the radius. So that way, if we have a very large radius, it is going to be still behind us. It is not going to eventually creep up in front of the player. At this point, we'll just need to add the two from one to the other, and that is going to go into our start and end. Now, I am going to need this information later, so I'm going to just select all of this, right click, collapse to function, and I'm just going to call it get trace location. And with it still selected, on the right in the detail panel, I'm going to select pure because all it is doing is just getting some values. It is not actually saving or modifying any variables. So now already, if I want to, I can change the draw debug type for 1 frame, hit compile, and then hit play. And you can see we have a small, slightly flickering circle behind us. And as I run around, you could see it is getting some hits within that circle. And those little hits, all those little dots are the locations of the foliage. They're too small to see. So great, we now have this working. So moving on from here, we're going to do a simple for each loop. For each of the things hit, let's go ahead and break it and open it up. Now, in my case, I'm only interested in the actual instance static mesh component. So from a hit component, I'm going to drag out and do a cast to instance static mesh component. It's the one all the way in the bottom here. And I'm going to plug loop body into that. So we know if it is true, then it is specifically an instance static mesh component. It'd be nice to get this as a reference. I'm going to right click on this output and promote it to a local variable. I'll just name it ISMC for instance static mesh component. And it is a local variable because I don't need it outside of this graph. The other thing I'm going to need is the hit item. So I'm going to right click on hit item, again, promote to local variable. I'm going to rename this to hit index because that is the index of the instance static mesh that we just overlapped. And then we can collapse this hit result and clean this up a little. So fantastic. We have the information. We're only going to do this when it is overlapping our specific PCG graph in this case. So now what do? Well, we take our instance static mesh component and then we just drag out and search for update instance transform. Now you want to do the singular one. You don't want to do the batch version. You want to do the single. And we're going to do that after the hit index. We're going to update it. Now the instance index here will of course be the hit index. So I'll just plug it in through here. And that transform we need to get. So I'll take the instance static mesh component variable again. I'm going to drag out and search for get instance transform, which gets us the transform of this instance. And then the instance index will be our hit index that we just saved. Now this is important. If it's world space, you want to set it to world space. In this case, we're keeping both relative. So we're making sure both are unchecked in the scenario. The only difference is I wanted to scale up because they're quite tiny. Now I am going to need to get the individual transforms. I'm going to right click and split the pin for the output here and the input over here. So we get access to location, rotation, and scale separately. We're not going to be changing the location or the rotation. We want them to stay the same, but the scale we want to slightly scale up as it does this. So from the get instance transform scale, I'm going to drag it out and search for a multiply. Now, I don't want to multiply by a vector. I want to multiply by a float. So I'm going to right click on the input pin, convert to a float. And in this float, I'm going to change it to 1.4, which I found is a good value here. You can, of course, play around with this value for yourself. And theoretically, we can already plug this in. The problem you will see quickly if we do it this way, and I was to hit play, oh boy, they grew so fast that, well, they're now completely out of view because they does grow really fast. So we want to limit how much you can grow. Now, the easiest way I find to do this is to split the output pin. So we have X, Y, Z separately because it's uniform scale. We can just use one of these values. And then we can drag out and search for a minimum. So min float. So whichever one of these two inputs will be smaller, it will use that one. So we take this and that is going to be our new transform scale. But what do we put in here? Well, here's the thing. If you do just a random float in range to make it between 0.25 and 1 as our second value, we'll have some issues. And that is if I hit play, they're dancing. Oh boy, they're dancing so much. And we don't want this. We want it to stick. So instead of a random float in range, I'm going to remove that and use a random float in range from stream. From stream is basically based on a seed. So this output is going to go into the min. The minimum value is going to be 0.25 to 1. Now, the reason I'm using 0.25 to 1, by the way, is because in our original transform points, that's the range that I gave it. You ideally want to keep it the same values here. So if it can only go up to 0.25 down or up to 1.0 in height, you don't want to go crazier once you kind of grow it, or it's going to look weird once you actually swap it to the one that saves and reloads, and it's going to be a jarring difference between what you wanted originally in the PCG graph and what you're getting. So how do we do this actual seed? Because stream is a random stream structure. Well, it's very simple. All we do is drag out and search for make random stream. We don't want to do it from location. We just want to make random stream. This gives us a seed we can pipe in. And the seed that we want to use is the hit index. We want to make sure that every single specific point that we're scaling is scaled the same way based on it. So now at this point already, if I hit play, you could see they're no longer jumping around. And if I run around, well, we're already spawning the foliage around us. And so as I run around, you can see the little points behind us are all tracing, and they're growing all the way to full height. It is not just a snap in, which is why we're doing it about 100 times a second, and we're scaling it by 1.4 in our case. And if I run back, the trees do have collisions, and I'm fine not walking through the grass. I think at this point, we can go ahead and turn off this debug for the multi-trace, but we now have effectively a way of spawning things behind us dynamically at runtime. What we don't have a way of doing yet is loading it after we have quit. Now, I'm not going to go in super depth on saving and loading mechanics in Unreal. I am going to show how to set up a basic one, but just know there's a lot of tutorials on YouTube for setting up a save and load system. So if you want more in-depth and understanding of how everything works and why it works the way it does, I recommend checking out one of those videos. In our case, I want to go ahead and record the path that I took and the radius of around where and that I am actually, well, getting and growing the stuff from. Because if my radius increases or decreases, I want to update automatically. In fact, for testing, in the event graph, I'm going to search for debug key, and we can just use any one of these. Debug key tab, for example. So when I press the debug key tab, something will happen. Now, this is for debugging only. At this point, you should be using the enhanced input actions. For debugging, though, this is fine. All we're going to do is get ourselves a random integer, and the exclusive max, we're going to set it to 4, and then we're going to drag out of it and do a switch on int on pressed. So it's going to do a random value here. On switch on int, I can turn off has default pin to be off because we don't need it, although you could keep it on, it doesn't really matter. And then we're just going to add 4 outputs here from 0 to 3, and all we need to do is set the radius to something when we go out of each one of these. So if I go ahead and just set this up, we could say on 0, it'll be 0. On output 1, it'll be 50, then 100, and then 150. So now if I hit play, I can just run around. And if I hit tab, we can potentially get a smaller one or a larger one, depending on what it randoms to. You could, of course, make the values different. This is just for testing, but we want to make sure we keep this. So if when we get to a smaller trail, it saves the fact that we're going on a smaller trail. So event begin play is where we're going to set this up. I'm going to detach the timer here from it. And I'm actually going to use a sequence. So that way we can keep this a little bit more organized. Then one will be our set timer by function name. Now, because we're going to need the reference to this graph, and I don't have one set up already in the world, I'm going to use the simple version, which is just to get the actor of class from the world. If you already have a reference to the graph somehow with your character, you don't need to do this, of course. You just use that reference. In my case, I don't. So all I'm going to do is drag out and search for get actor of class. We want just a singular actor, not multiple. And the actor is going to be our BP_forest that we created. It is our blueprint. And then we're just going to right click on this and promote it to a variable. And let's call this BP_forest reference because we're going to need it in a moment. Now, for the save game, we're going to need some things, starting with the actual save game components. So I'm going to right click, go to blueprint class, and I'm going to open up all classes. And I'm going to search for save game. And I'm going to grab the regular save game here and hit select. I'm going to call it something like SG for save game _forest. You can have multiple save games. You don't need to have everything in one save game. So we can just make a save game specifically that saves only the forest here. I'll go ahead and open it up. And the only thing we're going to need to save here is a single variable, which is going to be our transforms of where we're actually running, how wide we're running, what the radius is, what the location is. The rotation doesn't really matter, but scale and location does. So that's why we're going to be using a transforms. So I'm going to just call this trace transforms. It's going to be of type transform. I'm going to right click to make it an array. And then I'm going to hit compile and save. And that's all we need here. So now in the blueprint third person character, we can actually check if there is information for this. And then I'm going to search for does save game exist? Because we want to know if a save game already exists, because we're going to need to load it if it does. And if it doesn't, then we don't. Now, the slot name here, I'm just going to call it forest. But we're going to need this slot name in a few places. So at this point, I'm going to right click and promote it to a variable. And I'm going to just leave this as slot name. That is fine for me in this case. You can, of course, name it the forest slot name, forest save name, etc. The user index is 0 because this is single player world. And now we can check, does it exist? Yes or no? Well, if it doesn't, we need to make it. So on false, we can search for create save game object. The save game object is going to be our SG_forest that we made. You see it right here. And we're going to need to create a reference to this. So out of return value, I'm going to right click, promote to variable. And I'm going to name it SG_forest reference. So fantastic. It is going to go ahead and create it. Now, at this point, I would actually like to generate the forest because this is the first time we're going here. So in our world, I'm going to select the BP forest, and then I'm going to scroll down to the PCG graph here, and I'm going to do a cleanup. I want to zero out this forest so that way, if I hit play, nothing is spawning anymore. Nothing behind me, nothing anywhere. And this is because we set it to on demand previously, and on demand, when nothing is generated, will not actually load it on load, which is what we want. But at this point, we need to load it. So I'm going to grab our BP forest reference, drag out and search for get PCG. We want the PCG variable here. And then I'm going to drag out and search for generate. And we're going to make sure it is set to force. Force is there so that way if it is not generated, it will make sure to generate it still. Otherwise, if this is off, if I recall correctly, it will not generate an ungenerated thing. It will only regenerate a generated thing. If the save game does exist, untrue, drag out and search for load save game from slot. Now the slot name is our slot name that we saved, so I'll just plug that in. User index still 0. From here, we're going to cast to our SG_forest. So I'm going to do cast to SG_forest. It'll be the only one that comes up. And then from as SG_forest, I want to go ahead and set this SG_forest reference. So now we're going to have access to this variable. Fantastic. So from here, I can drag out of it and then get trace transforms. So we have all of those locations. And I want to store those on the blueprint graph that spawns the PCG. So on here, I'm going to add a new variable. I'm going to call this just grown forest because this is the part that's going to be already grown on load. It'll be a type transforms. It's going to be an array. And I'm going to hit the eye icon to make it actually exposed so we can use it in the PCG graph later. For now, though, we will return here. We're going to get the forest reference, PCG, and generate. We're going to need those a little bit over here. We can drag out of BP forest reference and search for set grown forest, and we go ahead and set it with the trace transforms. And then that goes into generate. Same thing as below here. So wonderful. We have all this, but here's the thing. We're not still saving to it. We're loading to it, but we're not saving to it. Well, there's two things left. One is we need to make use of that information in the PCG graph, and two, we actually need to store the information. We'll go PCG graph first. When we actually store the information, we'll immediately see a result. Otherwise, we'll kind of need to work a little bit backwards. So in our PCG graph, I'm going to right click, get actor property. Now this is where you're going to need to plug in the property name, which is the variable you set here and made exposed. So I'm just going to select it and copy it and plug it into the property name here. Now by default, this will not have any information because the actual array is blank, but don't worry. As long as it throws you no warnings, that means it sees this property name. It has found it, so everything's going to work just fine. From here, we need to convert it to a point information. So I'm going to search attribute to point, and we want attribute set to point. We want this conversion right over here. And then from here, we want to set the actual transform information, which is all of the transforms that are stored on here, onto the actual point locations. Now this is very easy to do. I'm going to just drag out and search for set attribute and go ahead and grab it. Now we want the input to be the same thing from both, but in the details of the set, for input source 1, we're going to change it to be a point transform. And where's it going to get the information from? Well, it's going to get it from here, from grown forest, because it will have an attribute called grown forest already attached to it. So if I go ahead and type that into input source 2, we should be good. Now for demonstration, what I can do here is select grown forest and add a couple of transforms here, and one of them I can say, let's say 100 on X for demonstration, and 2X on the Y scale. Now, if I go back to our blueprint forest here, and I go ahead and regenerate it, so we have something in the world, you can hit clean up and generate again, so generate something. We can go here and just press A on the set, and you'll see that here's our 2 points that we added. The position of one of them is 100. The scale on that point is also 2, just as we set. And if I press A on the get actor property, you'll see our original information did not have any point information. It just had the grown forest position, rotation, and scale, which is why we set those transforms onto the actual point information. If I scroll all the way to the right, you'll see the actual attribute information is still there in case you need it later. In my case, I'll go ahead and clean up this grown forest back up. I'll also make sure to re-clean up the graph to ungenerate it from the world. At this point, we just spawn something from this information that we're going to be sending it. Now, we're not going to be spawning the actual foliage again. That'd be too much. That means we would need to save tens of thousands of points. Instead, what we're going to be doing is spawning a trail behind us and spawning spheres. So from here, I'm going to use a simple static mesh spawner. I'm going to add a simple entry here, and I'm going to change the static mesh to be here, an editor sphere. The collision will maintain no collision. We do not want to actually collide with this at all. The only thing we need here is if we search hidden in game is to make sure the hidden in game is turned on so we don't actually see it. But this will spawn in the spheres where we want. And now we need to not spawn the dynamic version where these spheres exist. So from this transform points, which in our case, I'm going to set a new comment here to be 0.001 scale, so we know which one that is. So from the 0.001 scale, we drag out and search for a difference node. Now the difference I'm going to change from minimum to binary, and the static mesh spawner will go into the differences. At this point, I can go ahead and plug this into the static mesh spawner. So it'll just not spawn them where these are. Great, but we want to still spawn them where they were. We just don't want to do it on every individual point. We just want to do it on the area because again, this is just a sphere. So all we need to do is use a simple intersection node. From the original select points before we scaled them down, that is going to go our primary source. And our source 1 for the intersection is going to be our spheres here. And now we're going to need to spawn the static mesh spawner again. So I'll just duplicate this down and plug this in. Now, I still need to make a change on this static mesh spawner, and that is if I search for collision, for some reason in 5.6, the collisions gets reset to this instead of what we just had. So you want to watch out for that. For our seedling, we're going to just change everything to ignore. We don't want any kind of collisions here. But for our actual tree, we want to just turn everything on ignore except pawn, so that way we still collide with the trees. And because the seed of both of these, this one right here, is going to be the same, it should place them in the same locations. So fantastic, right? We have things working, but again, this is not saving and loading it. So final step, I'm going to have another timer to save it. So I'm going to duplicate this timer by function name, drag it over, and I'm going to make a new function here, and it's going to be save forest. I'm going to copy the name, and instead of grow forest, it'll be save forest, and I'm not going to do it quite as often. I'll only do it at 0.05 because I don't need to save it that much. You can also absolutely save it on demand, but we'll do it this way for simplicity. In the save forest here, we're going to need to get our get trace location because we need to know where we are in the ground behind us. And then we're also going to need to grab the save game reference. Then we need to get trace transforms because that is the variable we saved in the save game reference. And we just want to do a add unique because we don't want to save a transform on there multiple times if it's the exact same location. From here, let's make a simple make transform so we can get all three separated out. The trace location is our location. The rotation doesn't matter because we're working with a sphere, but the scale does. And the scale is going to be our radius divided by 100. And then what I found works really well is to then divide it again by 2.75. That gets a really good approximation from what I can tell of actually what we see as we run through to what is actually being spawned. Because as you recall, because it is a sphere that we're tracing when we run through it, the things at the very edge of the sphere don't grow to full height. It almost has a fall off effect as we run, because the longer the point is within our actual sphere, the more it has a chance to actually grow to full length. So by cutting off a little bit on the inside, we effectively replicate roughly what we actually expect to see visually. So at this point, we go ahead and plug that into scale. And now we've set the transforms on the save game, but we actually need to just save the save game at this point. So this part here that comes after this, you can do manually a single time when you need to. In my case, I'll just put it onto this timer for simplicity. So from the save game forest reference, I drag out and just do save game to slot, plug that through, slot name, same as before, we just plug in the slot name for user index 0. So now let's check everything out. If I hit play, there's a little patch behind us. I can go ahead and run. Things spawn right behind it. If I press tab, I can get a different size. In this case, it's 0. Press tab again. You can see we can kind of draw out the world here, and we can have a nice area here, but we had that before. Now, if I go ahead and just stop running, we can see what our little area here looks like, and I press escape, and then I press play again. After a moment, you can see there it is back exactly how we had it. In fact, if we run around and slightly trace it, you can even see there's the jump I made. There's a little gap. Now, it's not going to be exactly perfect. If we had a small tree here, like this one right here, this is a small tree. This tree might not be exactly that small when we quit and replay. It'll be in the exact same location, but you can see the one next to it, this one right here, is bigger. And that's because the randomness within the actual blueprint when we actually scale them might have not reached the full height that it was going to do between 0.25 and 1, or it might have just been a different value than the seed you would have gone on the point from PCG itself. So the locations will be the same. The scale will be slightly randomized within that point. But let's be honest here. If you were to spawn this, you probably wouldn't be paying attention to this. This is not going to be what the thing is that people care about when actually dealing with this game. They'll be like, wow, it's saving the environment. I can actually draw out my own stuff here. Awesome. So again, if I want to, I can just run around, spawn some more trees, however I'd like. And when I go ahead and just decide to, okay, I'm good here, quit. Here I am in the blank level, play, and there's our level back, and there's a little run that we did, all saving. Now, this is already really cool, but I have one other thing you can use this for, and that's to kind of make it into a game. Now, we probably have heard of the game Splatoon, where you kind of paint the world. You could probably use this for a actual 3D comparison game. Now, how do you get the information of like who wins and who loses? Well, you could actually kind of get that already inside of PCG. This top one is how much has not grown, and this bottom one is how much has grown. So from here, all we need to do is drag out and get point count, and we want to do the same thing on the bottom one, and then all we need to do is drag out a print string. This one is from newer versions of Unreal, so if you're in the previous versions, you might not have this. We're going to plug this point scout into the print string, and on this print string, I'm going to turn on print on screen. We're going to leave it to be blue. Let's go ahead and duplicate it over. Again, plug into print string. And this version, we'll go ahead and just make it something like green. And if I hit play now, you'll see in the top left corner, 3,400, 74,000. So you know how much of each there is. So if you had, for example, two traces that were using two things of different tags or two different sets of transforms you were saving for different players, you can compare the two and just use a simple branch in PCG and then using a post function, trigger something in the blueprint based on who won. Now that might be a little bit confusing, and if it is, that's okay. I am thinking for the next video of showing you guys exactly how to actually get all variables from your PCG graph into the blueprint that spawned them. Now, it's not a super simple way, but you'll be able to get the exact values from the PCG graph into the blueprint. So if you're interested in that, please let me know in the comments below. But besides that, enjoy your world that is now spawning and saving as you would like. We can now just paint the world and make it as interesting or as cool as we would like. Now, as always, the project files for this will be available on the Patreon, where we can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord will be down below as always. And if you're looking for more awesome PCG tutorials, check out this one right over here, which is one of my favorites.